This formula is the capital asset pricing model. Now, this formula is actually the equation of a line, and when this line is graphed, the line is referred to as the security market line. Well, we use the capital asset pricing model to help us determine the required rate of return on a security. Part of the equation includes the risk-free rate. The risk-free rate of return, for example, it might be the return on a 90-day treasury bill. We also have in our formula the return on the market portfolio. Now, the return on the market is really impossible to measure because the market is so huge. So what we use in this formula is some sort of proxy for the market, some rate of return that will represent the market return. It's pretty common to use the return on the S&P 500 or perhaps the return on the Wilshire 5000. Also in our formula is beta, which, as we know, is a measure of an asset's non-diversifiable risk. So, our required rate of return is equal to the risk-free rate plus the return on the market minus the risk-free rate times beta. Now, in parentheses, the return on the market minus the risk-free rate, this has a special name. It's called the market risk premium. As we can see, it's the amount over and above the risk-free rate that investors require before they will invest in the market. Now, when we take the market risk premium and we multiply that times the beta for asset I, this gives us the risk premium on security I. This is the amount of return over and above the risk-free rate that investors require before they will invest in security I. This takes into account the systematic non-diversifiable risk of security I. So, our required rate of return on an asset is equal to the risk-free rate of return plus a risk premium to compensate the investor for the riskiness of that asset. The formula for the capital asset pricing model, as we said before, is actually the equation of a line. So when the capital asset pricing model is graphed, the line itself is called the security market line. Now, the SML, the security market line, shows us the relationship between an asset's systematic risk, as represented by beta, and the asset's required rate of return. Assets with greater risk are expected to provide higher rates of return. In fact, we can see that an asset that has a beta greater than 1 would plot at a higher place on the SML, which implies a higher required rate of return. Conversely, an asset with a beta less than 1 is going to plot on a lower point on the line, which indicates a lower required rate of return. So higher betas generate higher rates of return, lower betas generate lower required rates of return. Now, the capital market line looks somewhat similar, doesn't it? The capital market line helps us determine the required rate of return on a portfolio, and we see that the required rate of return on a portfolio is equal to the risk-free rate plus a portfolio risk premium. Now, the premium for the portfolio is equal to the market risk premium, which is our term in brackets again, multiplied by the standard deviation of the portfolio. So it's the risk premium that investors require before they will invest in this particular portfolio. The formula for the capital market line, as we see, is very, very similar to the formula for the security market line, but there are some major differences. The first major difference is that the CML is used to define the risk-return relationship for diversified portfolios only, whereas the security market line can be used to show the relationship between risk and return for any asset. Any individual asset, any portfolio, or any well-diversified portfolio. Another major difference is that the CML uses standard deviation as the risk measure, whereas we remember the SML uses beta to represent risk. Let's assume that Treasury bills are generating a return of 5%. The return on the Wilshire 5000 is 12%. So we've got a 5%, which is representing our risk-free rate, and the return on the market is going to be represented here by 12%. NIST satellite systems returns are 20% less volatile than the market. Calculate the required rate of return on KSSI stock. Well, let's begin with our formula. Using the capital asset pricing model, the required return on an asset is equal to the risk-free rate plus, we're going to have the market risk premium, which is RM minus RF, times the beta of the stock. Okay? Now we've got the risk-free rate of 5%. We've got the return on the market is 12 minus our 5%. And our beta is going to be 0.8, isn't it? Because we are told that the returns of this stock are 20% less volatile than the market. The market has a beta of 1, and so this stock has returns that are 20% less volatile. It's going to have a beta of 0.8. This generates for us a required rate of return of 10.6%. Okay? The stock market is expected to generate an 11% rate of return. The standard deviation of the market returns is 15%. Nelson Hydro Products returns are consistently 20% more volatile than are the market returns. If the risk-free rate is 4%, what is the required rate of return on this asset? Let's start with our formula. R sub I, the required rate of return, is equal to the risk-free rate plus the return on the market minus the risk-free rate times the beta of the asset. The risk-free rate is provided, it's 4%. The return on the market was given as 11%. And the beta of the asset is going to be 1.2, because these returns are 20% more volatile than are the market returns, and we know that the market has a beta of 1.0. So when we multiply this and add, we get a required rate of return of 12.4%.